So last time I explained about Rutherford's model. It was pretty simple. This you have done in probably class 9 or 10th, also probably 9 standard. I'll dictate, and if required, I'll keep on explaining if you feel so. So write down second model. Number 2, Rutherford's nuclear model. Rutherford's nuclear model of an atom. Within brackets, write down 1911. This was proposed in 1911. Why is the year important? That I'll tell you when I dictate you when I explain this part. Write down. Rutherford bombarded a thin gold foil of approximately 100 nanometer thickness. You know, 1 nanometer is 10 to the power minus 9 meter. 100 nanometer thickness with high energy alpha particles which carry 2 units of positive charge and 4 units of mass. If you remember, last time I told you about alpha particles. Alpha particles are nothing but a combination of 2 protons and 2 neutrons. And the mass of 1 proton is equal to mass of 1 neutron, almost equal. So mass of 2 protons and 2 neutrons is 4 units of mass, and the charge on 2 protons is 2 units of positive charge, right? So gold foil was bombarded with this type of alpha particles. Continue. Main observations made during the experiment and conclusions drawn from them are: number 1. So there were 3 main observations made during the experiment, and on the basis of those 3 observations, 3 very important conclusions were drawn. I hope you know. First observation was that most of the alpha particles pass straight through the gold foil, and from this it was concluded that there's large empty space present in an atom. So write on number 1, most of the alpha particles passed straight through the foil. From this, it was concluded that there is large empty space in an atom. Within brackets, approximately 99.9%. So that was the large empty space present, and through this empty space only alpha particles passed straight. Number 2, second observation. See, second observation made was that few alpha particles, they pass with a slight deviation in the angle. Now, which alpha particles were these who suffered slight deviation from their path? And why did they suffer slight deviation? See, alpha particles are positively charged, and if there is deflection probably should be from positive repulsion. It means in the atom there is a positively charged body which is repelling positively charged alpha particles, right? So from this, it was concluded that there is a positively charged body present at the center of an atom. Now, if there is a positively charged body present at the center, then which particles are these which are deflected? Alpha particles. These alpha particles are the ones which pass close to this positive body. They did not strike it, they passed close to this body, and due to slight repulsion, they were deflected through small angles. So write down second observation and conclusion. Uh, few alpha particles were deflected through small angles. From this, it was concluded that positive mass is not spread throughout, contradicting Thomson's model, not spread throughout, rather it is concentrated in a very small body and deflected alpha particles are those which passed close to this body. Number 3. Now, third observation was that approximately 1 out of 20,000 alpha particles, they were deflected through very large angles of 90 degree or more than 90 degree. Now, these alpha particles which were deflected through large angles, these were the ones which struck this positively charged body directly. Due to direct collision between positive alpha particles and positive body at the center, they were rebound or they were deflected through large angles. Now the question is, if alpha particles which have high energy strike this positive body at the center of atom, then why is this body not displaced from its position? This is not displaced because this body at the center of atom is heavy. When alpha particle hits it, alpha particle is deviated, but this body at the center does not leave its position. It is not deviated from its position. So one conclusion is this body at the center is heavy. Second conclusion, why only one particle out of 20,000 deflected? This proves that this positive body at the center is very small in size. So these were two conclusions drawn. Right on number 3. Approximately 1 out of 20,000 alpha particles were deflected through large angles of more than 90 degree. From this, it was concluded that positive body at the center of atom is heavy. Only those alpha particles are deflected through such large angles, reflected through such large angles which directly strike the body, which directly strike the body. Also, since number of particles deflected through large angles is very small, it shows that the positive body is very small. So two conclusions from the last third observation: positive body is heavy, and second is positive body is very small in size. Now, on the basis of these observations and conclusions, Rutherford proposed an atomic model. Now we'll study about that atomic model, which you'll find very easy. Right, our next paragraph. Based on these observations and conclusions, Rutherford gave his atomic model, whose main points are number one. The very first and very important point is that he said this positive body at the center, he named it as a nucleus. He said there's a heavy positively charged body called nucleus present at the center of the atom. And the size of this nucleus is roughly 10 to the power minus 15 meter, whereas the size of an atom, radius of, I'm talking size means radius of the atom is approximately 10 raised to the power minus 10 meters. So there's a difference in the radii of nucleus and atom to the tune of 10 raised to the power 5 times, right? So compared to atom, size of the nucleus is very, very small, right? On number one, an atom has a small and heavy positively charged body called nucleus at its center. Nucleus at its center. It carries almost entire mass of the atom. Almost entire mass of the atom. Its radius is approximately 10 to the power minus 15 meters, while radius of the atom is approximately 10 raised to the power minus 10 meter. 10 to the power minus 10 meter. Radius of nucleus can be calculated by using the formula that R is radius of nucleus is equal to R naught into A to the power 1 by 3. A is mass number, which I told you earlier. This is number of protons plus number of neutrons, that is mass number. And R naught is a constant And the value of this constant is 1.33 into 10 to the power minus 30. Right? This will be the answer in meters. This will be radius in meters. Second point. Positive charge of nucleus. Positive charge of nucleus is due to the presence of protons, but its mass is due to the presence of protons and some other neutral particles, within brackets write down, which were later discovered as neutrons, in 1932 by Chadwick. See, in the beginning, when I said write the year of this theory, Rutherford's model, you had written 1911. See, Rutherford's model was proposed in 1911, but neutrons were discovered much later. They were discovered in 1932. So Rutherford did not know that some neutrons like particles are present. He just said positive charge is due to the presence of protons, but mass is due to the presence of protons and some neutral particles. And these neutral particles he did not name. These neutral particles were later discovered by Chadwick, were named as neutrons. Right? Third point. Number of protons is equal to number of electrons in a neutral atom, which is called atomic number. You already know about this point, which is called atomic number. Within brackets, symbol small letter Z. Fourth point. Electrons revolve around the nucleus in circular paths called orbits. Thus, Rutherford's model is comparable to the solar system. See, how come this is comparable to solar system? He compared sun with the nucleus of atom, and he compared electrons revolving around nucleus. He compared these electrons with planets which are revolving around the sun. So compare with the solar system. Next point, and the last point rather, electrons and nucleus have electrostatic attraction due to opposite charges, electrostatic attractions, which are counterbalanced by centrifugal force. I hope you know what is centrifugal force. You want to study it in physics, but still, let me tell you. If we take 10-20 grams piece of marble, tie with a string and revolve it, then you'll have the feeling that your hand is being pulled outwards. This force which is pulling you outwards, this is called centrifugal force, but you are pulling it inwards so that it does not fly off. That force which you are pulling it, that is called centripetal force. So centrifugal and centripetal force, they are balancing each other. Now, in this case, centripetal force is nothing but force of attraction between positive nucleus and negatively charged electrons. So this electrostatic attraction is acting as centripetal force, and centrifugal force is due to its motion around the nucleus. They balance each other, right? That is why he said the atom is stable. Now, although this is a very old model, it was almost the beginning of structure of atom. It was the second theory. Naturally, there were many drawbacks. We'll consider two very important drawbacks of this theory, due to which this model was rejected. So write on next topic. Drawbacks of Rutherford's model. Rutherford's model. One very simple drawback was he said electrons are present outside the nucleus in orbits, but he did not mention how many electrons are present in shell number 1 or 2 or 3 or 4. It means distribution of electrons in various orbits was not given, and what is the energy associated with these electrons, that was not explained by Rutherford's model of atom. So write on number 1. First point, he did not give distribution of electrons in various orbits and energy associated with them. Second point is a lengthy point, is a very, very important point. Listen to me carefully. It will take time to explain. See, if we are driving at a particular speed and we have to take a turn, you might have observed we have to slow down when we take a turn, right? Similarly, electron is revolving around the nucleus, and since this is a circular path, it means electron is changing its direction of motion at every moment. And if it is changing its direction of motion, it is turning, it means it should slow down. But if electron slows down, then centrifugal force will decrease. I told you about revolving that stone tied on a string. If you revolve at a high speed, you'll have the feeling centrifugal force acting outwards is more. And if you slow down, centrifugal force will decrease. So if electron is changing its direction of motion, it means it should slow down. And if it slows down, its energy, centrifugal force will decrease, means energy will decrease. And if energy decreases, it means electrostatic attraction between nucleus, positive nucleus, and negative electrons will become stronger compared to centrifugal force. But it is found that electron, when moving around the nucleus, it is traveling at the same speed, same energy. There's no loss of energy. Now, there is a theory which is called Maxwell's theory of electromagnetic radiations. This theory says that if a charged particle, electron is a charged particle, This theory says that if a charged electron particle has to maintain its speed while turning, if it has to maintain speed, naturally it has to be under acceleration. Then only it will maintain its speed, otherwise it should slow down. And if the charged particle is under acceleration, theory says in any case it must lose energy. And if loses energy, then centrifugal force will decrease, centripetal force will increase, electron will come closer and closer and closer to the nucleus. And some calculations will show that it will take just 10 raised to power minus 8 second for the electron to come closer and closer and strike the nucleus. It means atom should be unstable. But it is found that atom is quite stable. Electron does not come closer to the nucleus and strike it. This doesn't happen. So stability of the atom was not explained by Rutherford's model. So that is the main point of this theory, drawback of this theory. Now write down. It's a lengthy point. Point number 2. While revolving in an orbit around the nucleus, direction of motion of electron continuously changes. This should decrease energy, that is speed, which does not happen. It means to maintain its speed, electron is under constant acceleration.
So to maintain its speed?
To maintain its speed, electron is under constant acceleration. But according to Maxwell, Maxwell, according to Maxwell's theory of electromagnetic radiations, if a charged particle is under acceleration, it must lose energy. However, if electron loses energy, its centrifugal force, the one acting outwards, its centrifugal force will decrease, and it should come closer and closer to the nucleus, and ultimately collide with the nucleus. Calculations show that it will take approximately 10 raised to the power minus 8 second for the 10 to the power minus 8 second for the electron to spiral into the nucleus. What's the meaning of spiral? I'll tell you. Spiral into the nucleus, and atom should collapse. An atom should collapse. Now, what is the meaning of spiral? This is positively charged nucleus at the center of atom. Electron is revolving around the nucleus. Now, if its centrifugal force decreases, it will slowly come closer and closer and closer to the nucleus. How will it come closer to the nucleus? It will spiral like this, come closer and closer and closer and closer to the nucleus. This is the meaning of spiral into the nucleus, and it will take just 10 raised to the minus 8 second for this electron to spiral into the nucleus. That is, it should strike the nucleus in 10 to the minus 8 second. And if it happens, it means atom should be unstable. But we know that the atom is stable. So stability of the atom was not explained by Rutherford's model. Continue. Thus, according to this model, an atom should be unstable, which it is not. Now, maybe in the next class or in next to next class, you'll study about spectrum. Now, if the loss of energy is gradual, slowly it is losing energy, then the spectrum of hydrogen or spectrum of any atom should be a continuous spectrum. Although you'll not be able to understand what's the meaning of continuous spectrum, it should be a continuous spectrum. But it is found that the spectrum is not a continuous spectrum, it is a line spectrum. Although what is the meaning of line spectrum and continuous spectrum, you'll learn either in the next class or next to next class. But just write one sentence about it. Next paragraph. Moreover, if electron loses energy in a continuous manner, spectrum obtained should be a continuous spectrum. Continuous spectrum is like rainbow, but not a line spectrum. Line spectrum will appear as if there's a barcode on something you are buying. Lines are visible. So it's not a lines, should not be line spectrum. Last line. It means Rutherford's model does not explain stability of atoms. Does not explain stability of atoms. So this is the reason Rutherford's model was discarded. So we have considered two models, Thomson's model, which of course is not important. Rutherford's model is important to some extent in 11th standard. Before we take up other models, we have to take up some intermediate topics. On the basis of these intermediate topics, we'll switch on to third model of an atom, maybe after 2 to 3 classes. So there are some topics which have to dealt with in between. Right, on next topic, a smaller one will take up nature of radiation. Nature of radiation. See, what is radiation? Light which is visible to us, light coming from the bulb, from tube light, from sun, that is visible light. But at the same time, there are radiations which are not visible. So whether it's a visible radiation or invisible radiation, this is nothing but transmission of energy in the form of waves through space. Means what? Let us say radiation. Let us say radiation is moving in this direction. It means energy is moving in this direction in the form of waves. And these waves are combination of two waves. One is electric waves, the other is magnetic waves. Electric and magnetic waves, they are perpendicular to each other. If electric waves are like this, it means magnetic waves will be perpendicular to this. So both are perpendicular to each other, and they are perpendicular to the direction in which radiation is moving. Now we have to understand the terminology, various terms which we'll be using in with reference to radiation, like what is the speed of radiation, wavelength of radiation, then frequency, amplitude, and there's one more which is called wave number. So these five terminology will finish today. It will take just 5 minutes. Right on. Any radiation, whether visible or not, whether visible or not, is the transmission of energy through space in the form of waves. These waves consist of electric and magnetic fields which are perpendicular to each other and also perpendicular to the direction of movement of radiation. That is why any radiation is called electromagnetic radiation. Electro from electric field, magnetic from magnetic field, electromagnetic radiation. These waves do not require medium to travel. It means they can travel through vacuum as well, but sound waves, they need a medium to travel. But electromagnetic radiation, they do not require any medium to travel. Characteristics of radiation are: number one, speed. Within brackets, symbol is small letter c. Small letter c is the symbol for speed of any radiation. At a speed of all types of radiation, is 3 into 10⁸ meter per second, called speed of light. Number two, wavelength. Within brackets, symbol is lambda. See, let us say radiation is moving in this direction in the form of waves. What is lambda? Lambda is distance between two adjacent crests or distance between two adjacent troughs. That is called lambda. It is the distance between two adjacent crests, CRESTS, crests or troughs. Crests or troughs. Its units are units of length. Units of length like centimeter, meter. NM is nanometer. I hope you know 1 nanometer is 10 to the power minus 9 meter. PM, picometer. 1 picometer is 10 to the power minus 12 meter. Or angstrom. This is nanometer, 10 to the power minus 9 meter. Picometer, 10 to the power minus 12 meter. Angstrom, 1 angstrom is 10 to the power minus 10 meter. So this conversion unit you should remember. Third parameter, frequency. Frequency. Within bracket symbol is nu. This looks like small v, but it is a bit twisted. This is nu, nu. That it is the number of waves which pass through a point in 1 second. Which pass through a point in 1 second. Its units are hertz. Hertz is written as capital H, small z. Hertz or kilohertz. Obviously, 1 kilohertz will be 1000 hertz. Or second inverse. Or we can say cycles per second. All have the same meaning. All have the meaning second inverse. Adam, also C is equal to nu lambda. Remember this relation. This will be used in numericals. C, that is speed of light, is equal to frequency into wavelength. Next, number 4, amplitude. Amplitude. Symbol is small letter A. See, this is amplitude. And it is the height of a crest or depth of a trough or depth of a trough. Its units are the units of length. Units of length. I told you many units of length earlier. Same will be used here. Last, wave number. Wave number is nu bar. Symbol is nu with a bar above it, nu bar. It is the number of wavelengths per unit length. Number of wavelengths per unit length. That is, write this relation. Wave number is equal to 1 by lambda. Its units are meter inverse or centimeter inverse. Means inverse of length. So these were the parameters related to radiation.